In mathematics, linear interpolation is a method of curve fitting using linear polynomials. Linear interpolation between two known points. If the two known points are given by the coordinates and the linear interpolant is the straight line between these points. For a value x in the interval, the value y along the straight line is given from the equation, which can be derived geometrically from the figure on the right. It is a special case of polynomial interpolation with now equals a1. Solving this equation for y, which is the unknown value at x, gives, which is the formula for linear interpolation in the interval. Outside this interval, the formula is identical to linear extrapolation. This formula can also be understood as a weighted average. The weights are inversely related to the distance from the endpoints to the unknown point. The closer point has more influence than the farther point. Thus, the weights are and, which are normalized distances between the unknown point and each of the endpoints. Interpolation of a data set. Linear interpolation on a set of data points is defined as the concatenation of linear interpolants between each pair of data points. This results in a continuous curve, with a discontinuous derivative, thus of differentiability class. Linear interpolation is approximation. Linear interpolation is often used to approximate a value of some function f using two known values of that function at other points. The error of this approximation is defined as, where p denotes the linear interpolation polynomial defined above. It can be proven using Rolle's theorem that if f has a continuous second derivative, the error is bounded by. As you see, the approximation between 2 points on a given function gets worse with the second derivative of the function that is approximated. This is intuitively correct as well. The curvier the function is, the worse the approximations made with simple linear interpolation. Applications. Linear interpolation is often used to fill the gaps in a table. Suppose that one has a table listing the population of some country in 1970, 1980, 1990 and 2000, and that one wants to estimate the population in 1994. Linear interpolation is an easy way to do this. The basic operation of linear interpolation between two values is so commonly used in computer graphics that it is sometimes called a loop in that field's jargon. The term can be used as a verb or noun for the operation. For example, Bresenham's algorithm loops incrementally between the two endpoints of the line. Loop operations are built into the hardware of all modern computer graphics processors. They are often used as building blocks for more complex operations. For example, a bilinear interpolation can be accomplished in 3 loops. Because this operation is cheap, it's also a good way to implement accurate lookup tables with quick lookup for smooth functions without having too many table entries. Extensions, accuracy. If a CO function is insufficient, for example if the process that has produced the data points is known be smoother than CO, it is common to replace linear interpolation with spline interpolation, or even polynomial interpolation in some cases. Multivariate, linear interpolation as described here is for data points in one spatial dimension. For 2 spatial dimensions, the extension of linear interpolation is called bilinear interpolation, and in 3 dimensions, trilinear interpolation. Notice, though, that these interpolants are no longer linear functions of the spatial coordinates, rather products of linear functions. This is illustrated by the clearly non-linear example of bilinear interpolation in the figure below. Other extensions of linear interpolation can be applied to other kinds of mesh such as triangular and tetrahedral meshes, including bar copyright Zia surfaces. These may be defined as indeed higher dimensional piecewise linear function. History. Linear interpolation has been used since antiquity for filling the gaps in tables, often with astronomical data. It is believed that it was used by Babylonian astronomers and mathematicians in Seleucid Mesopotamia, and by the Greek astronomer and mathematician, Hipparchus. A description of linear interpolation can be found in the Almagest by Ptolemy. Programming language support. Many libraries and shading languages have a loop helper function, returning an interpolation between 2 inputs for a parameter in a closed unit interval, 0, 1. This function is used for alpha blending, and the formula may be extended to blend multiple components of a vector in parallel. See also, bilinear interpolation, spline interpolation, polynomial interpolation, de Castelgeau's algorithm, first-order hold, bar copyright Zaya curve, references. Menigering, Eric, A Chronology of Interpolation, From Ancient Astronomy to Modern Signal and Image Processing, Proceedings of the IEEE 90, 319/342, doi, 10.1109/5.993400a. External links, Equations of the Straight Line that Cut the Knot, Implementing Linear Interpolation in Microsoft Excel, Haswinkel, Michiel, ed., Linear Interpolation, Encyclopedia of Mathematics, Springer, ISBN A978-1-55608-010-4, Haswinkel, Michiel, ed., Finite Increments Formula, Encyclopedia of Mathematics, Springer, ISBN A978-1-55608-010-4, C. Orange-Al Solutions for CUDA Implementations of Linear Interpolation. APLJAK Linear Interpolation Calculator, one of many calculators available.